All right, guys. So today we are going to look at quadrilaterals, and to be specific, we're going to talk about parallelograms. Okay, so parallelograms, remember, we talked about that opposite sides are parallel. So opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are equal to 180. The diagonals bisect each other. And each diagonal creates two congruent triangles when we split them up. Remember, we talked about the top and the bottom. So now, that takes care of all parallelograms. Now we have special parallelograms, rectangles, rhombus, and squares. They each have their own properties to add to the 6 that are already up here. So for example, a rectangle. A rectangle by definition is a quadrilateral with 4 right angles. So rectangles have congruent diagonals. So we would say that AE is congruent to RL. So, and rectangles have 4 right angles. Okay, so angle H equals 90 degrees. The measure of angle E equals 90 degrees. The measure of angle L equals 90 degrees. And the measure of, that is an L. And the measure of angle A equals 90 degrees. So a rectangle has these 6 properties, and the diagonals are congruent, and the angles are right. Okay, our next figure is a rhombus. Okay, so a rhombus is a quadrilateral with 4 congruent sides. So rectangle has 4 right angles. A rhombus has 4 congruent sides. Now, the big thing about a rhombus is that the diagonals are perpendicular. So remember, that's the symbol for perpendicular. So if you need to write it out, so they are perpendicular. So that means that the measure of angle TSE, which is this angle right here, that means it's 90 degrees. So if that one's 90, all 4, it's 90 all the way around. So you get 4 little right triangles. Now, each diagonal, so we got 2 diagonals here. So each diagonal of a rhombus, it bisects the opposite angle. So for example, this angle right here, TAL, is now 2 equal angles. So I got TAS and LAS. So for one example, we would say that the measure of angle ZEA, so this angle right here, so ZEA, if it's been bisected, it's congruent to LEA. So this piece is equal to this piece, and this piece is equal to this piece, and all 4 of those pieces are equal because remember, opposite angles are congruent. So if these 2 angles were equal, and then I cut them in half, now I have 4 equal pieces. And then don't forget, that's a right angle in there. So now I have 4 right triangles. So a rhombus also has 4 congruent sides, which is the definition, but it's also one of the properties. So a rhombus has these 6 properties plus 3 more. Rectangle has these 6 plus 2 more. Our last one is a square. A square has these 6 plus these 2 plus these 3. So altogether, a rhombus, or a square is a rectangle, a square is a rhombus, a square is a parallelogram. So a square is so special that it just has everything. So there's 6, 7, 8, 9, 10, 11 properties that a square has. So you could think of it like this. They could have named it a rectombus or a rhombangle. It could have been named anything other than a square. All right, so now go to the next page. So let's talk about how do we apply those properties to math. So a rectangle is a quadrilateral with 4 right angles. So with 4 right angles. And if a parallelogram is a rectangle, then the diagonals are congruent. So that means that RT is congruent to SU. So RT is congruent to SU. So if the diagonals are congruent, then that means they're also equal because of the definition of congruent segments. So if I substitute this in, RT is equal to 6x plus 4, and SU is equal to 7x minus 4. Then I can solve for x. So if I subtract 6x from both sides, I get that 4 is equal to x minus 4. And if I add 4 to both sides, I get that x is equal to 8. So if x is 8, if you go back and plug it in, so you've got 7 times 8 plus 4, so 56 plus 4, so 60. So that means both your diagonals have a length of 60. So now you try. So quadrilateral EFGH is a rectangle. Since it's a rectangle, the diagonals are equal. So I would say HF is congruent to GE. So HF, or FH, either one, 5x plus 4 is equal to 7x minus 6. So I'm going to subtract 5x from both sides. I get that 4 is equal to 2x minus 6. I'm going to add 6 to both sides. Now I've got 10 is equal to 2x, and I'm going to divide by 2. So x is 5. All right, next page. All right, so we're still talking about a rectangle. And remember, a rectangle has equal diagonals, equal opposite sides, and all these angles are 90. Don't forget, all these angles are 90. So that means that if I were going to find x, then I know these two angles add up to equal 90. So that means 5x plus 8 plus 3x plus 2 equals 90. So if I combine my like terms, 5x plus 3x is 8x. 8 plus 2 is 10. And all that still equals 90. So if I subtract 10 from both sides, I get 8x here. If I subtract 10 here, I get 80. If I divide both sides by 8, I get that x is 10. So when x is 10, then that means 3 times 10 is 30. 30 plus 2 is 32. So that means this angle up here is also 32. So if I wanted, I could also find y, because now I know that this angle is 32 because of alternate interior angles, because remember these sides are all parallel also because it's a rectangle, and a rectangle is a parallelogram. So I could go over here and go, well, 6y plus 2 is equal to 32. So if I subtract 2, I get that 6y equals 30, and if I divide by 6, I get that y is 5. So now I was able to find both, but I had to find x first. And don't forget your main properties. All right. Now what about the diagonals? So if Kyle is building a barn for his horse, he measures the diagonals of the door to make sure that they bisect each other. So remember, if they're equal and they bisect each other, then you have 4 parts that are all equal to each other. So if he wants to make sure that this is the midpoint, if he does that, then he will be able to ensure that all these angles are 90, because if the diagonals are equal and they bisect each other, then the corners are going to be 90. So we know that AC is congruent to BD. So a parallelogram with congruent diagonals is a rectangle. Therefore, the corners are right angles. All right, now let's get back to math problems. All right, so now quadrilateral ABCD has the vertices A, B, C, and D. Determine if it's a rectangle. So if I wanted to determine if this was a rectangle, So a rhombus is a quadrilateral with 4 congruent sides, but these sides are not congruent, so it's not going to be a rhombus. So the diagonals of a rhombus are perpendicular. The diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. So these are all terms for vocabulary that you need to know. And these are also your properties for a rhombus. But I want to know if this is a rectangle. So to be a rectangle, this has to be 90, and these two pieces, BD, has to be congruent to AC. So if I'm going to determine if this is a rectangle, then let's check and see if we have 4 right angles. So I'm going to find the slope of every side. So I'm going to find AB slope, then I'm going to find the BC slope, then I'm going to find the CD slope, and then I'm going to find the DA slope. So if I find all 4 slopes, 2 should be the same, and 2 should be negative reciprocals. So AB, so we're going to go draw our little, let me get this out here. So let's draw my right triangle here. So I've got 1, 2, then I've got 1, 2, 3, 4, 5, 6. So I rise 2, run 6. Rise 2, run 6, so that reduces to 1/3. All right, now BC over 1, down 1, 2, 3. Over 1, down, oops, I did that backwards. I need to rise over run, not run over rise, sorry. So this is 1, and this is 3. So I rise 3 and go backwards 1. So I rise 3, go backwards 1, which is -3. Well, these two are negative reciprocals of each other, so that means that's 90 degrees. So now let's check CD. So I'm going to go 1, 2. So I'm going to go down 2. Then I'm going to go 1, 2, 3, 4, 5, 6. So if I go down 2 and backwards 6, that's 1/3. Well, these two are negative reciprocals of each other, so these two are perpendicular. And then this one would be go over 1 and up 1, 2, 3, and up 3. So I went backwards 1 and up 3. Now these two, so 1, 2, 3, down 3 over 1, so that's -3. Now these two are also perpendicular to each other, as are those two. So I have 4 right angles. So by definition, a rectangle has 4 right angles. Okay, obviously my spelling is totally wrong today. All right, 4 right angles. So if I have 4 right angles, I got a rectangle. All right, now let's talk about a rhombus. I think my notes got a little displaced. I think these properties here should go on that other page with the actual rhombus. So let me just do this. I'm going to, I don't know if that actually, yeah, that didn't work. Let's cut that. So let's go back here. It's going to be a little choppy, but it'll have to work. All right, so let's cut this and let's see. Scoot this over and let's put our properties here with the rhombus. So we'll just slide them up there. All right. So now, to know if it's a rhombus, remember, you have to have 4 congruent sides. You have to have diagonals that are perpendicular. And the diagonals bisect your opposite angles. So the diagonals bisect your opposite angles. So if this diagonal cuts these 2 angles in half and they were already equal, now I've got these 4 equal parts. And then these 4 are going to be equal to each other also. And angle 1 is 90 because remember they have to be perpendicular. And then these four sides all have to be the same. So I have four little right triangles that are all the same. So since angle 1 is equal to 90, then I can substitute in angle 1. So y squared minus 54 is equal to 90. And then it says to add 54 to both sides. So if I add 54 here and I add 54 here, I get that y squared equals 144. And then you want to take the square root of both sides. So y is 12. So remember, when you take the square root of something, it can be positive or negative. But since we're in geometry, length can't be negative. So in this case, it's not going to be, because when you square a negative, it's going to become positive. So either one of these could be correct. All right, so now let's look at find the measure of P in L. P in L. So they want us to find this answer right there, that angle. So if P in M, and this is N, if P in M is equal to, so this angle here is equal to this angle over here. So remember, opposite angles are congruent. So angle MLP, and MLP is 64, so if this angle is 64, then this angle over here is also 64. But remember, 64, P and M is also going to be 64. But remember, the diagonal cut that angle in half. So that means 64 over 2, or 32 degrees. So now you know that all of these little angles are all 32. And now I could even go even further, because since this is a right triangle, and I'm going to redraw that, it's not going to be pretty, but I'm going to redraw it. Okay, I'm just going to, this is this corner right here. Okay, I know this is 90, and I know this is 32. Now I can find this one, because these two have to add up, so that would be 58. So now this one's 58, this one's 58, this one's 58, and this one's 58. So with rhombus, once you find one thing, you can almost find every single thing else, because it's so easy. And if I wanted to find the sides, I could use my SOHCAHTOA or trig to find the lengths of the sides. So you could find everything about a rhombus because it's all equal to each other. All right, the last one we have here is a square. Okay, a square, remember, is a parallelogram, a rectangle, and a rhombus. So what we're going to do is, if they want us to explain if this is a square, a rectangle, or a rhombus. So what I'm going to do is, first of all, I'm going to check and see the slope of my diagonals. Because if the slope of my diagonals are negative reciprocals, then that means they're perpendicular. And if they're perpendicular, then that's going to make it either a rhombus or a square. And then if I check and see if they're the same length, then that's going to make it a square. Because if you have diagonals that are congruent and perpendicular, it makes it a square. So what I'm going to do is I'm going to draw my diagonal. So from here to here. And I'm going to find the slope. Okay, so let's find the slope of this. So we're going to rise. Oh lordy, let's try a different color here. So we're going to rise, and then we're going to run. And I think I went up too far. And then we're going to run. So using rise over run to find the slope of your diagonal AC. So AC slope. We could use slope formula too, because remember, slope formula is y2 minus y1 over x2 minus x1. I could just use the numbers. So I could go 2 minus negative 1 over 3 minus negative 2. And two negatives make a positive. So I would get 3 over 5. So to double check, I'd go 1, 2, 3. 1, 2, 3, 4, 5. So 3 over 5. So the slope of AC is 3 over 5. We'll do the same thing with BD. So BD slope. So if I do the same slope formula, so if I do negative 2 minus 3, and then positive 2 minus negative 1. So this would be negative 5. 2 negatives make a positive. 2 plus 1 is 3. Since these are negative reciprocals, that means that my diagonals are definitely perpendicular. So now I would just say that these are definitely perpendicular. And since they're both 3 over 5 and 5 over 3, that also makes them congruent. So I know this is a square because the diagonals, here, let's do it this way. I have a better idea. I'm going to say it is a square because the diagonals are perpendicular and congruent. Ta-da! There, now y'all can read it. So it makes it a little better. All right, so we'll go over this more in class, and I will see y'all next time.